So for our intake, we're going to do a drop-down sort of small intake. So and then the intake is going to pick up from the ground, going to go into a hood mechanism, so it's just a wheel surrounded with a C shape. That's going to fling it up into like a belt, I guess, or something.
Flywheel system.
Flywheel system, and then it'll just shoot out a hood, and we'll have a turret, I believe, at the top. And then we'll also have a pretty cool climber.
We just learned that we only have one stage climber, singular NMR climber, so that we would have a NMR climber and then two passive hooks on either side of it. So one, it will climb on the left side of the vertical bars of the climber, and then it would attach the passive hooks as it climbs to the next stage. So it will do that until it reaches the third one. And for auto, it will just stay at the bottom and it would not activate the passive one. So then once auto is done, the battery robot will not get any power, and then we'll just drop to the floor and we can drive out. That will get us the ranking point, and then we'll have a turret with a tame drive, so it's easier for defense and we can just go over the ramp. That's it.
Yeah, I think the storage capacity is like 9 balls, 8 balls.
Yeah.
Somewhere around there.
Yeah, we sacrifice storage space to prioritize climbing, so we can get balls out faster.
You go into the details of like how a game piece would move through your robot, kind of like walking us through each step, how the intake contacts it. I didn't see too many details about your indexing system or any way that you move balls through the robot. Do you have that at all? And then move us through it going out the chute.
Yeah, so the robot, the ball will be on the ground, and then we will have the drop-down intake, put it up into this cutout area, and then from the cutout area, our indexer is the hood mechanism, so it's just a wheel inside of a C shape, and that'll fling it up into the flywheel, and then the flywheel will shoot it out the top. The flywheel will be on the turret, so it can aim in any sort of direction.
The hood would also help with the arc that the ball is going, so we can shape the hood to the point where it would actually make into the place. But then it would also have side wheels as an indexer, so once it intakes the ball using flywheels on the bottom, then it will intake it and go through the indexer, which will help it go through the flywheels at the top for the shooter.
So you are planning to have one wheel to essentially move balls through the robot, but you want the robot to store 9 balls? How is that?
It will have, it's 3 different flywheel systems basically. 2 this way and 2 sideways, so like it indexes, and the indexer wouldn't be working on, so we can keep the storage up, we can add more balls as the robot's intaking it, but the index would only work when we want to shoot.
Sure. So if we split this into components of, you have an intake that has a certain set of wheels to move balls into the robot. You have an indexer, which it sounds like you have like 5 wheels total that make up the indexing that move balls to the robot. Is that what you said?
Yeah.
Okay. And then it goes to a
The
shooter.
shooting system, yes.
Yep. Do you have any details on whether you require a shooting system to have an adjustable hood and a single flywheel or 2 flywheels, or not really?
It will have maybe 2 flywheels, and the hood will be a fixed position, and which would need testing to figure out what that angle of that or position of that hood is.
So does this robot doesn't have pitch, it sounds like? It doesn't have like motorized pitch? Does it have motorized yaw?
Yeah.
Okay.
Can you go into what does that mean?
Because it sounds like it's gonna, correct me if I'm wrong, right? It's got a hood that is optimized so that the balls come out and go at a specific angle, so you can shoot from basically any distance. But then it has a pitch, so you don't have to be like facing the.
It will just correct based on the April tag that we could detect vision.
So I think you would call that a turret, essentially.
Yeah,
Yes.
that's what you said, turret.
Yeah.
Take turret.
And any considerations on electronics, battery, any things that you guys figured out with that or not really?
So ultimately, all of our mechanisms are pretty small. Our storage area and front mechanisms are pretty small. So the electronic can fit sort of around it pretty easily.
Since it's small to work with.
Yeah.
I'm wondering if you guys could go a little bit more into why you chose tank drive specifically for your robot, like some considerations.
So we chose tank drive because tank drive is really good at being just an immovable object. So if we want to block off a path, we just turn sideways to that path. No one's gonna go through that.
And we have a turret, so there doesn't need to be much of a smooth movement when we're shooting, so,
It also lets us go over the bump,
yeah.
Over the bump.
Yes.
because it's sort of in the can, a lot more trouble.
Is there a question in the back?
No.
Okay.
Is this design short enough to go underneath the trench? Or is it only gonna go, over the bump?
It's gonna be short enough because the elevator is just gonna retract to the most common level.
And then the actual height of the shooter doesn't need to be high.
Right.
I'm kind of wondering if like it'd be worth considering like having the robots like storage area be even taller, just because if you're using tank drive and over the bump, we might take advantage of having that vertical area, you know? And maybe we could consider like having taller walls that we can just decide to remove if we feel like they're not worth it, or maybe the taller walls that like maybe they get pushed down when we go under the bar or something like that. Do you guys think that'd be reasonable, or do you think it'd be worth it, those kind of things?
A little bit later modification, but yeah.
I guess.
Yeah, we could definitely have like maybe a wall that goes over that, and then walls there and there and there, and then those could be whatever height we want. They could probably hold a similar capacity to if it goes all the way up, even if it doesn't go all the way up, because those just stack on top of each other without the walls being there, which would make it harder to go under the thing
Yeah.
if we max out the capacity.
I think we're gonna close to time, but I think one small comment I have is I think the visualizations are a little limited. If if you do have some time, any extra drawings of like what you guys planned out here to help with that voting system would probably help. Because otherwise we're doing a lot of imagination.
We can add pictures as well,
Sure.
the other teams presented too.
That'd be awesome. All right.
Merging our teams, our strategy didn't really change. We kept the climber from team 1, and that was just due to the fact that it was much simpler, less moving parts. Do we want to play this video? Because that's like how our climber is going to work.
It's basically the same thing as described before. You just have a one-way latch go on, the climber in the box moves up, and the one-way latches.
Yeah, because there's just one moving part here, and then there's a static latch, which we would basically just do that for fun.
Full screen if you guys want.
Full screen.
Yeah.
One thing to note is we wouldn't have this movement here. We would not need it. So it will just be stationary one-way latches. Climber in the box moves up and just latches on to the next one.
We still want to use a turret and with a hood as well, so we can shoot from different distance away from the thing. And then, yeah, the next slide has a lot of details.
The reason that we would use that turret in the hood is because of our strategy. We would be shooting balls into our zone, and we would be able to do that. And as we're moving, shooting, and if we just had a stationary hood, we wouldn't be able to do that. And then it allows us to basically shoot anywhere from inside our zone.
Are you saying to, in the neutral zone, shoot balls over into the line
Into
zone?
our alliance zone.
You guys checked that it's legal to launch?
Yes,
Yeah,
it's
we
legal to
couldn't
launch.
find anything against it. I don't know if anyone else saw anything against it, but we didn't.
But you would shoot it into your zone, and so then when your hub activates, you'd be able to just sweep through and just shoot.
Okay, so I'll first talk about the intake. So with our mechanism drive, the motors stick out. So we have, this is gonna be it's gonna start inside, and then it's just gonna be like a string reel with like spring loaded. So it'll just reel out to deploy, and when balls go in, it can move slightly to help it, and then it'll just come in here and drop into our chamber.
The chamber itself is actually the best part of this because you can make it as big as you want because we'd just be using cardboard or a plastic box you bought from Target. In this thing, we are using you can actually fit about 35 balls in this example. And the way that it would work is it funneled into this turret, this like little assembly, actually this would be better right here. The balls would funnel in because the angle or the cardboard or plastic, whatever you want, is angled just to filter it right in. And what would happen is you'd have compliant wheels pushing the balls up into the turret. Like I said before, turret would move around plus or minus 180 degrees for full 360-degree rotation. And we'd have the turret hood be able to move up and down. And that could be accomplished using either gear racks or timing belts or whatever you want to do for that.
And then our climb. It's just a climber in a box, 2-staged, low enough so that it'll stay under the 22 inches. But it's angled in such a way that when it extends with the bumper right up against like one of these, it'll extend to the point where it gets out of the frame perimeter, latches on, pulls down to a static latch like here, fixed latch. And so like you saw in that video that had 2 latches. And after it does latches on this, it'll extend again, and our bumpers will just drag up against this because we want to climb like either right here or right here, so that our bumpers will ride up against this so they don't get caught under. And then we just repeat that.
The neat thing about that is if the CG of the robot is too far this way, the bumper will brace it. If it's too far this way, the bumper will still brace it. So as long as the CG isn't like on this side, isn't just like all the way over here, we should be fine. Oh yeah, and everything as designed fits under the trench. This box right here,
It's not in the other one.
it
does fit under the trench.
Yeah, everything will fit under the trench, which we made sure to design around that.
Okay, now questions for Sean?
Do you have any active mechanism in your storage to make sure the balls don't get stuck in there?
Yeah, so when we were talking about this, we were thinking about adding like just a kicker or a flywheel, because when the balls would go in, the biggest issue would be jamming. So making sure that there's no like too aggressive angles, and making sure that it's like there's nothing jutting out into it. So like if we had a 90-degree angle, what's a good thing? If this was at a 90-degree angle with this, it wouldn't funnel in correctly. So as long as we have like a nice angle going in, it wouldn't jam. But if that comes up, we would have like a kind of compliance wheel kicker to just push the balls in.
So where is this compliance wheel? Is it under your shooting?
Yeah, so it's not listed right here, but because of the way that it's angled, the balls will naturally fall into the compliance wheel lift.
Yep.
And there should be actually
So
2
is
sets
it-
of compliance wheels, so even if the balls were kind of getting clogged up here, it wouldn't jam because there's already a compliance wheel here that kicks it in, and then it latches on to other compliance wheels that kind of just kick it up. So even if it were to be clogging up there.
So it's one wheel at your entrance. That just
Yeah, there's a one.
Okay.
Another thing is we just need to get the balls, feel how slippery they are, if they like stick to each other, and then just prototype that.
So are you're indexing them just by letting them roll or fall towards the
Mostly, yeah.
base of the turret?
It'd
We
be-
need a prototype if that works. If it gets stuck, then we need to add more stuff. We'll get the balls tonight.
If it doesn't work, we can fall back to our conveyor belt design, but this is just for simplicity and saving time in construction. If it does turn out that's an issue, which I don't believe it will be, we can add kind of like a conveyor belt kicker agitator, and that'll solve the problem. Yeah.
Sorry I missed this. Do you have an adjustable pitch?
Yes.
Yeah, the hood is adjustable.
It should be relatively easy to make.
Because we're doing calculations, and if you want to shoot from like different distances away, you basically need a fixed or movable hood.
Different distances being like, different parts of the field, not necessarily different parts of the
Yeah.
side.
If we did,
Yeah, well, from your aligned zone, if you want to get score from like right up to it, right up next to it, and like over here, you need a variable pitch.
the way the strategy that we came up with works is if you scrape through the neutral zone when your thing is off, you'll just be shooting the balls all over your alliance zone. And so when your alliance becomes active, you just kind of sweep through and the turret will just fall with the be able to shoot.
Yeah, ideally we're gonna be like driving slowly, picking up balls as the turret's shooting while we're driving, while it's active. Anything else?
Let's move on to the next set of presentations. Whoever the
Just send the entire team up there.
Sorry, everybody else.
I put those images on our slide if we want to.
Do you want to go first?
Yeah, sure, I can go first. And the first thing I want to talk about is the turret, probably. That's what I'll start with. Currently an adjustable hood, and it also has a yaw that moves. You're pretty confident that we'll be able to design this. The other thing is we can always de-scope it. It is 3 days, so we can always de-scope it to just a static hood. We were thinking if the rest of it gets too complex, we need to spend time on other things, we'd be able to do that. We're also talking about over the bumper intake. That way we wouldn't have to make any adjustments to the current bumper. Again, 3 days, so we want to make sure that our time management's well. We want to focus our resources on specific things. And adjusting the bumpers and chassis, it will be nice. We already put a lot of time into that previously this week. We want to make sure we're putting our effort into the active mechanisms that are specific to this game. Thank you.
Yeah, so as for intake, we were thinking, obviously over the bumper, but probably a 4-bar. As for how it retracts back, so actually, first thing I should talk about is how we're storing the balls. We're gonna have that turbine at the bottom, so it kind of sits down here, and then all the other balls will be stored above in a big sort of open basket. And so as the turbine spins, it kind of just feeds the turret. We should probably just watch that clip. So this is orbit in 2020, and it's a good demonstration of basically what this robot would look like. The hood could fold up, and then we'll just push the balls in like that. Yep.
The hood folds down to go into the trench, or into the trench.
Yep. So then instead of this robot, what our robot will be doing is storing the rest of the balls above where that turbine spins. So then as the turbine feeds balls in, the empty spaces will come out. Those will immediately get filled by the balls stored above. And then otherwise, I guess we do questions about that after, but we should probably talk about climbers.
Yeah. The other thing is, real quick, you can see up on that image, we have active, like the neck between where the agitator puts the balls into where the turret is, and the turret. There's belts to prevent any dead balls, so we can evacuate the entire container or the hopper, I guess.
We should talk about
Climber, you want to talk about climber?
Well, I think for the climber, correct me if I'm wrong, we were just thinking the same sort of passive active mechanism that the other teams were doing, where you have one that's kind of going up, and then you have the other passive where it can pull down.
Using a spring.
Yeah. Right.
So
I wasn't as much in the climbing top.
So it's one motor, and then you can climb onto the first bar without deploying that spring plate, and then the last climb, you can use that spring to climb the second bar and get 15 points.
Questions?
Questions?
Do you have any idea what the actual capacity of this hopper looks like versus other hoppers?
It could be customizable. I would compare it mostly to the Group B. Probably similar, probably a little smaller, but probably very similar.
Sure.
Maybe 25.
So you mentioned that the hood would just fully go underneath, so we can go underneath the bar, kind of like how Orbit did. How are you thinking of actually doing that with the packaging you guys have?
It's like in the video. So we want to fold the hood.
Mm-hmm.
So after folding, it's just gonna all fit under. I don't know if you'd have to fold it necessarily to fit it all under though.
Yeah, maybe, but basically this height will be under 22.5, which is the trench, and then the hood will fold back flat, and then you can just drive underneath. You're not shooting when you're traveling down, right there.
So is the hood then a material that collapses, or does the hood, does the C part of the hood like go into the neck?
Oh yeah, I asked you this morning. It moves, and there's a chain on the back, or some link, so, yeah, like chain link of some material
Yeah.
that will be in a sheath here, and then it folds out with this to guide the balls into the turret.
So you're
But
saying
that way the balls can still go straight up, avoiding the rest of the bottom of this.
So you're saying the hood would be made of like a chain, some like adjacent
Not the
material?
entire thing. The sides would be definitely metal, and
But
it
just the
would,
back
it would
part?
it would rotate around like a pivot here.
Okay, I
That
see.
makes sense.
And it's a 2 flywheel?
We're thinking two. One.
I think with shooters, we can definitely like get that specifics later on, but you can just take one main shooter and then a counter roller, and that's probably fine for most of these.
The nice thing about the turret is you can always, like you said, like scope down.
Yeah.
That it can be descoped, it doesn't need to be above 22, but like, it does provide an advantage of.
More space. In the
Yeah.
And less defense. Like it's harder for you for other teams to do defense on you if you're a turret fire, because they're less able to block you.
Can people play defense against you in the alliance specific zones at all?
So
It could be anywhere, I think, anytime.
Really?
No protected zones.
Wow. That's surprising.
so if you then it just
Go to
becomes
game.
will they move you if you're shooting.
Go to game apparently.
But also we were planning on having like this, the turret, because the yaw and the move, it just would automatically know where to shoot basically.
Yeah.
And have like two modes, like shooting into the thing, or just funneling balls from the other side into our alliance zone.
Can you give a quick location of where you want to put your climber?
Yeah, so we wanted, we just wanted the climber behind the turret. Having the center mass as close as possible to where you're climbing from is ideal.
We're also considering that you can put it on 3 of the sides. You can't put it on the intake side, but the other 3 sides you could put it on if your weight balance is weird, and if you think it's easier to move things around in a different direction.
Yep. Sounds good. Any other questions before we move to talking about the differences, pros and cons of these designs, and then voting?